1.3 billion years in the past. A pair of colossal black holes, locked in a dance of rapid orbits at 250 times per second, merged in a cataclysmic collision that sent shockwaves of energy rippling across the vast cosmos. In the aftermath, a new supermassive black hole emerged, dwarfing our Sun by over 60 times. Let's fast forward to September 2015, when the echoes of this ancient cosmic event finally reached Earth as gravitational waves. Fortunately, these waves had weakened considerably during their epic journey. But what if luck hadn't been on our side? What if a couple of black holes within our own solar system collided? Could we endure such an event? What would be the fate of Earth if colossal gravitational waves made landfall? What are the sources of these waves, and how do we go about detecting them? This is Universe Tour, and here's what transpires when Earth is struck by a gravitational wave. In 1916, Albert Einstein himself made waves in the world of physics with his groundbreaking theory of general relativity. He is famously known for the equation E equals mc, where energy equals mass times the speed of light squared. This theory revealed the interchangeability of energy and mass, as well as the warping of space or space-time in response to the presence of matter and radiation. With remarkable foresight, Einstein postulated that the collision of black holes or massive celestial bodies distorts gravity, and these distortions ripple out in all directions. Thanks to remarkable advancements in atomic precision, scientists in Washington and Louisiana at the Laser Interferometer Gravitational Wave Observatory, or LIGO for short, achieved a historic feat in 2015. They successfully detected and measured gravitational waves for the first time on Earth. This milestone marked the definitive validation of Einstein's theory of relativity. By utilizing laser interferometry, observatories can discern changes that are smaller than 1/10,000th of the diameter of a proton, which is 1 million times tinier than a human hair's width. Since then, LIGO has registered 50 instances of gravitational wave detections. Now, you might wonder what generates these waves, and do they pose any catastrophic threats? Gravitational waves have numerous origins, including the collision of black holes, the rotation of uneven neutron stars, supernova explosions, and even residual gravitational radiation traces from the Big Bang. These waves travel at the speed of light, emanating in all directions, like the ripples from a stone tossed into a pond. Fortunately, our position in the universe keeps us over 400 million light-years away from any revolving black holes. We're in a generally safe zone. Yet, should these black holes exist in our solar system, the consequences would be much more severe. When gravitational waves traverse a celestial body, one side undergoes compression while the opposite side expands, akin to squeezing a stress ball. This leads to the stretching of both time and space, causing a subtle wobble. However, if we were closer to such a violent cosmic event and the waves were significantly more powerful, the impact could potentially tear our planet asunder, setting off earth-shattering earthquakes, volcanic eruptions, and tempestuous storms. Earth would cease to be a hospitable place, except perhaps for extremophiles like bacteria that flourish in hydrothermal vents. Let's imagine a scenario where our Sun, a neutron star with an imperfect non-spherical shape, emits gravitational ripples as it spins. Earth would likely resemble Io, one of Jupiter's moons, experiencing substantial gravitational pressure from Jupiter. Consequently, it's one of the most volcanically active moons in our solar system. Our landscape would be dominated by lava and volcanic debris, while our atmosphere would consist of toxic gases like hydrogen sulfide. This would trigger extensive global warming and tumultuous weather conditions, characterized by constant tsunamis, tornadoes, and a state of climate chaos. We can consider ourselves fortunate, for we reside far from the influence of massive objects emitting gravitational waves. Nonetheless, we can continue to study and gain insights into the intricacies of our universe. Even though we are occasionally grazed by gravitational waves, they're typically so minuscule that we don't even perceive their impact. Conversely, if we were to suddenly lose our gravity, that would be a story for another video.